Last time we started discussing trigonometric equations. Let me do this kinda again. So we have a graph of a function y equals cosine x. It looks like that. Come in. So on. 0 by 2. So this function is neither increasing nor decreasing on the whole line, but it is monotonic on specific intervals. Later we will discuss that if a function is monotonic on an interval, there is an inverse function. So the solution of this equation, y equals f of x. So I'm looking at this interval from 0 to pi, and on this interval this function is monotonic. It is monotonically decreasing. So I am trying to solve this equation on this interval, and solution of this equation, yeah?
I think you get wrong point. It's not pi with pi over 2.
Yes, of course. Of course. Thank you. Pi is over here, this point. This is where it turns 1, this is where it turns -1. Yes, thank you. So, from here, from this point to that point, the function is decreasing. Yes. Now, the inverse function for this function is called arc cosine. I'm going to write y equals arc cosine, meaning that I have already switched y and x. You understand? The solution of this equation, x equals arc cosine of y, but I'm changing it so it goes the y as function of x. Okay, anyway, let's discuss the properties of this function. I think I have already drawn the graph of this function. So this is minus 1, this is y, this is 0, and this is 1. So the properties of this function, its domain of arc cosine is from -1 to +1. This is the domain. Its codomain is from 0 to pi. Codomain or range. We discussed that this is almost the same, but yes. This function is neither even nor odd, not even and not odd function, and it is decreasing. Now, we need this function no, we started at 10:45. This is 10:50 at right now. It's 10:50 right now. I'm answering the questions from the distance students. So I want now to solve an equation cosine x equals a. We already discussed that this equation only has solutions when absolute value of a is less or equal than 1. So I will write down that x doesn't exist if absolute value of a is greater than 1. And if it is between -1 and 1, then basically we want to I will do it here. So cosine is the x coordinate of our point. So we want to draw a line x equals a. This is the line. This is a. And we have two intersection points. Well, generally speaking, two. It could be 1 point if it just touches our circle, or it could be 0 points if absolute value of a is greater than 1. But generally speaking, it's 2 points. And you can see that one of those points is this value. This point over here, this is arc cosine A, namely this angle, of course. When I talk about points on the circle, I mean the angle. So this point is arc cosine A. And of course, if we add 2 pi, or maybe several times 2 pi, this will be the same point on the circle, but different answer. So this is arc cosine A plus 2 pi n. And the second point is the same, but the other way, so symmetrical point. So this is minus arc cosine A plus 2 pi n. So x equals plus or minus arc cosine A plus 2 pi n, where n is an integer. We can also look at this corresponding picture over here on this graph. If I look here, we have cosine x equals y. So let me draw a line y equals a. This would be this line, and this first point, arc cosine, is that point. This is minus arc cosine. And we, of course, repeat those points infinitely many times, and so on and so on. Okay, so this was arc cosine. Now let's discuss arc sine. This is roughly the same way, the same properties. So, what? No. 2. So this is function y equals sine x, and once again this function is not monotonic on the whole line, but it is monotonic on some intervals. Specifically, I will care about this interval from minus pi by 2 to plus pi by 2. And on this interval, the function is monotonically increasing. So we will later discuss that it has an inverse function y equals arc sine x, which looks like this. So this is pi by 2 minus pi by 2 minus 1 and 1. Its domain what you doing? Is once again from minus 1 to plus 1. Its codomain is from minus pi by 2 to pi by 2. This function is odd. Is an odd function, and it is increasing. And once again, we want to solve equation. Sine x equals a. Once again, we do not have solutions if absolute value of a is greater than 1. But we do have those solutions. I forgot to write it down over here if absolute value of a is less or equal than 1. Once again, I'm drawing a circle. And over here, I want to draw a line y equals a, because y is sine, the y coordinate of a point. So y equals a looks like this. We have 2 points. This one is arc sine a, and of course plus 2 pi n. And that one is pi minus arc sine a, and of course plus 2 pi n. Yeah. Once again? Oh yes, right, bigger. Okay. This is pi minus arc sine a plus 2 pi n. Okay. So solutions of this equation is we have 2 solutions. I will write them like that: x equals arc sine a plus 2 pi n, x equals pi minus arc sine a plus 2 pi n. This is provided that a, well, all of it provided that a is less than 1. Absolute value is less than 1.
Can you write in my arc sign bracket n pi plus minus 1 raised to the power of n?
Yes. Of course, those two sequences, those two series of solutions. Series is the wrong word. Well, basically, those two sets of solutions, I will write like this: x equals minus 1 power n arc sine a plus pi n. And if in this line n is an even number, then minus 1 power even number is plus. So we have arc sine a plus even times pi. That is the first line here. If n is odd, we have minus arc sine a plus odd number, odd times pi, odd number of times pi, which is the second line here. So this is the way to solve this equation. Okay, is this completely known to you? Anything new for you? Okay, Marta, this is a bad idea. You should write it down using your pen. Do not, guys. This is for everybody. If you are just taking pictures, then you are wasting your time. You should like spend actual time writing stuff down with your hand. It does make it easier to understand. If you want to have like something to read later, you have a lot of books. You don't need it. My explanation here is not an actual explanation. This is just to remind you what you should already know. So take your time at writing it down. So in the same way, I will maybe skip most of it. Maybe I shouldn't. Okay. So in the same way, y equals tangent x. The graph of tangent is like this. So 0, pi by 2 minus pi by 2. Once again, we choose one of the intervals, this one, where the function is monotonic. This is monotonically increasing function. And on this interval, we have a function y equals arc tangent x. Graph of this function looks like this. Pi by 2 minus pi by 2. Domain of arctangent is R. Codomain is from minus pi by 2 to pi by 2. This function is odd. function, and it is increasing. And once again, we can solve an equation tangent x equals a by drawing over here line y equals a. We have one intersection on the interval from minus pi by 2 to pi by 2. This intersection is the arctangent. This is arctangent a here. And since tangent is a periodic function, we have infinitely many solutions. Arctangent a plus pi n. The period is pi. So x equals arctangent a plus pi n. Okay, I think this is good enough for now. Any questions? Okay, what do we need? What do we need to discuss? Yes, a couple of examples. A couple of simple examples. So basically, solving any trigonometric equation is just doing something with the original equation using our properties of trigonometric functions like formulas, stuff like that, and then we like reach some simple equation like this, and then we write down the solution, or maybe multiple solutions. So examples. Example 1. Sine 5x cosine x minus sine 3x cosine 5x equals 0. First step is we use formula for what is this? This is sine of a subtraction. So this is sine of 5x minus 3x, which is of course just sine of 2x, which is 0. Then we use this formula to solve this equation. We write down that 2x equals minus 1 power n times what is arcsine of 0? Marta. Arcsine of 0. Okay, raise your hands, those of you who know the arcsine of 0. Okay, you please.
Arcsine of 0 is 0.
Yes, it's just 0. Just 0. Let me show you. Look. Arcsine of 0 is this point. It's just 0. This is, well, from definition, what is the angle such that its sine is 0? This angle is 0. Well, the angle from this interval. Anyway, arcsine of 0 is 0 plus pi n. plus pi n. Then we express x from here. X equals pi n by 2. And this is the answer. N is integer, yes. Yes. Okay, example 2. What was that? Like this. 2 times sine like that. Once again, we do like some manipulations with this equation to reach, well, some simple equation, like sine equals something. So from here we can express sine. We can write down that sine of pi by 6 minus x equals square root of 3 divided by 2. We can write, solve this equation. So we can write down pi by 6 minus x equals whom should I ask? You please, a guy in a hat. What's the arcsine of this number, square root of 3 by 2? Remind me your name, please. Jeremiah. What's the arcsine of this number? What's the angle such that its sine is square root of 3 by 2? Okay, you please. Pi over 6? No, not pi over 6. Once again? Pi over 3, of course. This would be, so the solution is minus 1 power n pi over 3 plus pi n. Pi over 3. But actually, in this case, it would be more convenient to write down the solution like that, as two separate sequences. Those are neither sequences nor series. I don't know how to call it. So I will write down this solution like that. X is, no, pi by 6 minus x is pi by 3 plus 2 pi n, or pi by 6 minus x is pi minus pi by 3 plus 2 pi n, which is of course just 2 pi by 3 plus 2 pi n. Now from those two equations, I will express x. So from the first one, x is pi by 6 minus pi by 3. This would be minus pi by 6 minus 2 pi n. And the second will be pi by 6 minus 2 pi by 3, which would be minus pi by 2, if I'm not mistaken. Minus 2 pi n. N is an integer number. And that is the answer. Okay, any questions? Any questions? Jeremiah, any questions? Okay. So moving on, yes, inequalities. Suppose we want to solve an inequality cosine x is greater than 1/2. It would be actually very easy to solve it looking at the circle, at the unit circle. So once again, I draw a line x equals 1/2. 1/2. We have two solutions of the equation. So we start by solving equation cosine x equals 1/2, then x equals plus or minus pi by 3 plus 2 pi n. Now, I want to solve an inequality. Cosine is greater than 1/2. We can look at it just by definition. Where are the points where the x coordinate is greater than 1/2? So this is where x coordinate is exactly 1/2, and it is greater than 1/2 to the right side of this line. So basically those angles. And we can write down the answer. So x is from minus pi by 3 to plus pi by 3. But since the function cosine is periodic, we have infinitely many intervals like this. Plus 2 pi n plus 2 pi n. N is an integer. Suppose we want to solve an inequality cosine x is less than 1/2. The picture is the same, but we need the left side, like this side of the circle, this arc. It would be wrong to write down this interval because this is the right side. We have already covered it. It would be wrong to write down, so I will write it wrong. Wrong way to solve it is to write from pi by 3. This point is pi by 3. And this point is minus pi by 3. This is true. But it would be wrong to write down like this. Marta, why would this solution be wrong? Well, why this expression is wrong? Okay, Jeremiah, could you explain why this is wrong? Yes, this expression says that this is a set of numbers that are bigger than pi by 3 but smaller than minus pi by 3. There are no such numbers. So this is wrong. This is wrong. We will not write it down like this. to write it correctly, we just need to express this function, this point as a different number. So if we start at pi by 3 and move on, when we reach here, the actual angle would be 5 pi by 3. So this, instead of pi by 3, we'll write 5 pi by 3. So correct solution would be x is from pi by 3 plus 2 pi n to 5 pi by 3 plus 2 pi n. Okay, any questions?
Like when we write 2 and pi, isn't it already implied that we are using intervals, not actual numbers?
Once again?
Like you said, pi was wrong earlier because it will be taken as number. But when we are using 2 pi n plus 2 pi n.
Oh, yes. I think I understand what you're saying. So this expression actually means that we are taking a union of all those such intervals where n is an integer number and x is from this union. So on the number line it would look like this. So this interval, the next interval, the next interval, infinitely many times to both sides. It would be still wrong to write like that plus 2 pi n. It will be still wrong because we'll basically be writing a union of empty sets, which is not what we want to say. So generally speaking, I agree that online lessons are less convenient. It's harder to learn and harder to teach, but I don't think we can do this today, because today you have you have different schedule, and I don't know even the room where we'll be. And I think when we will be learning online, no, offline, well, in a class, we will have a different time. I think I managed to move our seminars to, so it starts at 13:55, I think. Basically a different time. Something like this. So I don't think we can do this today, but starting probably next time, yes, of course we will. Too complicated. Too complicated. Okay, I think we can move on. Any questions about trigonometry? I want to move on to exponential function and logarithms. Also something you should know from school, but let me repeat a bit. So we have a function y equals a power x. Here I'm going to skip the discussion about raising any real number into any real power. So a and x could be any numbers. Well, not any numbers. I will demand that a is greater than 0. We can raise positive numbers. into any real power. I'm going to skip this part unless you want me to explain it. Guys, raise your hands, those of you who understand what it means to raise a positive number into like power pi or something. Okay, I see I should explain it a bit. Okay, before we discuss this function, let's discuss raising two powers. Suppose I have some number a. It's easy to raise it to power 2 or power 3 and so on. So we understand what it means to raise it to power n, where n is an integer number. We can also raise to negative powers, but it's not necessary right now. We also understand what it means to raise a to power 1/2. This is just square root of a. This is the solution of, this is a positive solution of an equation x squared equals a. We also, this was 1/2. We also understand how to raise it to power 1/3. This is a cubic root. This is the solution of equation x cubed equals a. And so on. We can raise a to power 1/m, where m is an, let's call it n. This is how I'm going to denote a set of natural numbers. Natural numbers are numbers 1, 2, 3, and so on, starting at 1. Combining those two ideas, I can raise a to power n divided by m. What are you doing? It does something strange. Yes, and n divided, what's going on? And n divided by m is a rational number. So we can raise any positive number into any rational power. Now, to describe raising a number into irrational power, I will actually have to cheat a bit. I will have to use the idea of a limit of a sequence, but we didn't discuss it yet, and this would be one of the main topics in our course. So I'm cheating here, and I'm using this idea, but we will discuss it thoroughly later. It's kind of okay to cheat that way because we will not be using this part, this idea of raising into real power, while discussing the idea of limit of a sequence. So you can imagine that this part I explained to you after we finished limit of a sequence, so maybe in a month time, something like this. So I want to raise a. What are you doing? How do I stop it from doing it? Whatever. I want to raise a to power r, where r is a real number. I will denote it as an infinite decimal. So this would be, let's call it b0, comma, b1, b2, and so on. For example, this number could be 3.1415, and so on. For example. And I'm doing this sequence of calculations. I'm raising a. What are you doing? How do I stop from doing it?
Maybe you set the screen that your pen.
No, I don't. No.
You should just write a little bit to the right side.
Once again?
You can just write look to the left.
Oh, maybe this is some weird area that does it. Okay, so I'm raising a power b0. b0 is an integer number, so I understand what it means to raise a to power b0. Then I raise a to power b0, comma b1. So in my example, that would be power 3.1. 3.1 is, of course, just 31 divided by 10. So this number is a rational number. And using this idea, I can understand what it means to rise into this power. Then a to power b0, comma b1, b2, which is also a rational number, something divided by 100, and so on, and so on. So this is a sequence of numbers. I understand what it means to calculate any of those numbers. And this sequence, this is the cheating part. I'm cheating right now. This sequence tends to, has a limit, and this limit, I will call this limit a power r. So the limit of this sequence is my definition of a power r. Okay? So this is the cheating part. But this is the general idea. Any questions? Raise your hands, those of you who heard something like this before. Not everybody. Okay. Guys, to be clear, do you understand why this needs to be done at some point? I expected that this was done at school, but it needs to be done at some point, because we are trying to build the building of mathematics, and we are trying to define what it means, everything that happens. What does it mean? We, of course, have to start somewhere, but those starting fundamental blocks, we should keep to the bare minimum. So we start with the very basic ideas like a set and very basic statements that we called axioms. This is not an axiom that we can calculate it. This is not a fundamental object. We can explain what it means to raise a number to some power. So it needs to be explained, and important part, I expect you to be able to do this on the exam. I'm not going to ask you to repeat school program, this part, during the exam, but I think starting from the next lecture, everything I'm explaining on the lectures, I expect you to be able to repeat on the exam. And to be clear, you are not allowed your notes on the exam. So you should like understand it good enough that you can write it from just your memory. Okay? And once again, do ask questions whenever something is not clear, because it's much harder to like figure it out yourself. Okay, moving on. So a power x. We already know how to raise any positive number to any power. By the way, do you understand why I ask only about positive numbers? What's the problem with negative numbers?
It's just 1 divided by this number of
Yes, we can easily raise any number to power -1 or -2. No problem here. It's just 1 divided by this number squared, for example. But there is a problem about raising to any power, non-integer power. What's the problem? Yes, let me explain it over here maybe. So suppose I want to raise maybe -3 to power 1/2. I can do this because I do not have square root of -3. I cannot have a square root of negative number. But so can't. I can't. But what if I try to raise -3 to power 2/4? By my definition, this means raising -3 to power 2, which I can do. The answer is 9. And then raising this answer to power 1/4, which is also something I can do. So this is I can do. This is I can do. I can do it. So to avoid this contradiction, I am forbidding myself from raising negative numbers into non-integer power. Much later, in the 3rd year, when we discuss complex analysis, we will explain we'll have a better explanation about these powers, and we will be able to raise like any number to any power, and it would be much more complicated than this. I mean, the answer would be much more complicated. So a power x, a is positive. We can draw the graph of this function. It looks like this. For example, maybe 2 power x or something like this. Y equals a power x. A is greater than 1. If a is greater than 1, it looks like this. If a is less than 1, I will try to draw it like that. This is y equals a power x. a is less than 1 but greater than 0. Looks like that. So, domain of this function, let's call it f of x. Domain of f is R. I can take any x, any power, and raise a to that power. Codomain is from 0 to plus infinity. You can see that, well, you can understand from the definition that I gave you that if a is positive and we are raising to any power, the answer will also be positive. Strictly positive. F is increasing provided that a is greater than 1 and is decreasing if a is less than 1 but greater than 0. This is the exponential function. Now, there will be a special case about exponential function. There is the best a for this function. There is a number. We will discuss it thoroughly later, and we'll explain why this is such a good number. I will call it number e. And this is approximately 2.718 and so on and so on. And we will discuss a function e power x. This is the best of exponential functions. Okay, this was the exponential function. Let's discuss logarithmic function. Let's start by discussing logarithms. Yeah. So, suppose numbers a, b, and c are such that a power c equals b. Suppose. Then we will say that c is the logarithm base a of b. So this is the power to which I need to raise a to get b. Okay? So, and we can see that this is kind of the inverse function of the exponential function. So, if we have y equals a power x, we can easily see that the inverse function x is log base a of y. And since we have the best exponential function, if y equals e power x, then we have the best logarithmic function, x equals log base e of y. And it is such a good function that we gave it its own name, it's a natural logarithm of y. ln, natural logarithm. In different other like branches of science, there are different other best logarithms. For example, in computer science, the best base is 2, of course. And in engineering, the best base is maybe 10, maybe, in some cases. But in calculus, E is the best base. It would be very convenient for us. We will see why later. Okay, so this is logarithm. Yes, the function itself. So the function itself. Let me y equals log base a of x. This is how it goes, provided that a is greater than 1, and this is how it goes, kinda. A is less than 1, greater than 0. Yes, I maybe should have mentioned it over here. Look, let's look over here. By the same, using the same idea about why a is positive over there, we can demand a to be positive over here. A is positive. Also, if a equals 1, then 1 power c, any power, is just 1. So if b equals 1, this equation have infinitely many solutions. 1 power c equals 1 have infinitely many solutions. So it's not very interesting. And if b does not equal 1, we have 1 power c equals something else, maybe 2. This equation does not have any solutions. Also not interesting. We will deal with only interesting part, which is a is not equal to 1. And of course, since a power anything is a positive number, a is positive number, power anything is also a positive number, I will demand that b is also a positive number. Okay, that's why I have those two cases, from 0 to 1 and greater than 0. And that's why, since b is a positive number, we have the domain of our function, domain of logarithm is from 0 to plus infinity. And codomain is just R. This is something we could have expected, because this function is just the inverse function of that function. Both black graph and red graph, yeah? Those are inverse function of each other. So domain codomain, this function is of course neither even nor odd, because the domain is not symmetrical regarding to 0. What else should I have said? Yes. Okay. Okay, moving on. So, logarithmic function. Now let's discuss some properties of logarithms. Once again, I expect you to know them by now, but just in case, I remind you, for those of you who doesn't know. log base A C B plus log base A C equals log base A B C. Raise your hands, those of you who already know this property. Already knew. Oh, at least this property is known. Okay. If we subtract, then this is the log of a quotient, B over C. What else do we need? Yes, if we have powers, log, the base of log would be A power M, where M is any positive power. And the argument of log would be B power N. And the answer would be N divided by M log B base A. So basically this power from the argument goes in front of the log as a factor, and this power from the base goes inversed in front of the log. What else? And change the base. Log base AB is log base CB divided by log base CA. Okay. There are more properties. I expect you to, if not know the other properties, but then just be able to derive them easily enough to solve something, to solve some equations. Okay, moving on. Now I want to discuss solutions of exponential equations and inequalities. Equations and inequalities. So, this is very easy. If I have an equation a power x equals b, then just by definition, provided that all of the conditions are met, just by definition, we can see that x is log base a of b. And I will repeat those conditions. I will demand that a is positive, a is not 1, and b is positive. So once again, if you have any equation with those kinds of expressions, something power x or something power something, you just do some simplifications until you get to this simple equation and then write down this answer. A bit more interesting is an inequality. A power x is greater than b. This is a bit more interesting. Once again, let me show you this picture. Look, if a is greater than 1, then this function is increasing, and if I draw a line y equals b, then the solution of an equation of inequality a power x is greater than b is like this part, from here and to the right, this part of the graph. This number is log base a of b, and the solution would be from this point and greater. Then x is from this point to plus infinity, well, basically greater than this logarithm, provided that a is greater than 1 and b is positive. If a is less than 1, then we have this red graph. This is a decreasing function. So the solution of equation is this one. This would be, I will write it in red, log base a of b. And the function a power x is greater than b from this point and to the left. So from minus infinity to log. Minus infinity to log ab, provided that a is less than 1 but greater than 0 and b is positive. Now, here I only talked about positive values of b. What happens if b is negative or 0? Jeremiah, what happens if b is negative? I want to solve an inequality a power x greater than b, where b is a negative number.
I think it's not possible because we said that a is greater than 0.
A is greater than 0.
And less than 1, so if we take it some degree, so it's not negative.
Yes, so a power any power is positive. That's okay. But what's the solution of a power x is greater than negative number? For example, let's solve an equation, an inequality. A power x is greater. Oh, let me do something specific. 2 power x is greater than minus 3. What's the solution here? Yeah. Yes, of course. 2 power x is positive number. So for any x, this value is positive and this value is negative. So this inequality holds. Can you see? And the same happens for any base and any non-positive value over here, value of b. So the solution of this inequality is x is any number provided that b is non-positive. And of course, the same kind of approach works for the opposite equation. So a power x is less than b. We will have, I will just write down the answer. So x is from minus infinity to log a b, provided that a is greater than 1, b is greater than 0, x log a b to plus infinity, provided that a is from 1 to 0, b is greater than 0. And this third line is a bit different. Well, basically the same, but a bit different. So since for any x, a power x is greater than this negative number b, then the solution of this inequality is just none. There are no solutions. So there are no solutions for this inequality, provided that b is less than 0. By the way, are everybody familiar with this sign? This means empty set. Is it familiar for everybody? Raise your hands, those of you who understand this sign, who understood the sign before today. Okay, Okay, so this sign means there are no elements in this set. So X is from such a set that there are nothing there. So basically that means there are no such values of X. We will need it a lot, this sign. Okay, my time is almost out, but I wanted to yes, I wanted to explain about this inequality, log base A of X, for example, greater than B, or maybe less than B, or stuff like this. So this inequality is solved just by using the properties of logarithmic function. The properties like increasing, decreasing, stuff like this. It's kind of more cases than this to write them all down, and I don't think it needs to be done. Just by using the properties of a function, we will be solving this inequality.